Okay, I'm going to share with you few issues and maybe a few problems linking to circular economy at a different scale, because I still believe that if you need to apply or try to monitoring some circular economy, you really need to identify which circular economy you want at different scale, and maybe what are the targets really you want to design. First of all, I hope you see my screen. Maybe try to understand. I propose to share this hour like 45 minutes between 3 and 4 parts. First part, I just would like to talking about. Before to start to design indicators, you need to design paradigms, goal, assumption, boundaries, because circular economy could, there is many definitions to define it. At the same time, if you want to measure, it's not only a problem of data, it's just the way on target you fix inside. So I would like to spend a few time to explain why do we need to design this and why it's important. Starting this before to discuss about methods, and after, at the end, try to design indicators for circular economy. So this will be my second part. Make the connection with the methods, because I think sometimes we forgot that behind the indicators, there is some methods, there's some design of research. And we have to understand if you start to design, like using a specific methods, you cannot have a very broad, large spectrum of indicators. You have limited indicators. And for the moment, I think this is a problem. We are too much restricted indicators and much at the micro levels, which is not really good if we have, and if we want to understand the global view of the circular economy. The third part will be, I will question the different indicators from Europe, because, since 2015, we are involved in a new designing of indicators. And since 5 years, we try to fix every waste with inflows and outflows in Europe, try to match and grasp every indicators. And last part, I will talk about the comments, concluding remarks I have today, and maybe we could have discussion of that. First of all, I just coming back to the goals, not the goals that we said goals are linking to circular economy. It's just goals that we expect to be in circular economy. And in my opinion, for the moment, the connection, it's a very huge connection to pollution issues, and no to the flows of materials, of energy we need to produce. We need to have for human activities, what we can connect to the planet boundaries. I think it's very important to understand how much flows, how much stock do we use today, and why do we use these flows and stock for human activities, which means it's not possible to measure a circularity which grows every time. Circularity grows with the economic activity. So if your economy is growing, circularity is growing too. I think it's very important to understand that when you measure something which is getting higher and higher, bigger and bigger, it's very hard to understand what is absolute and what is relatively. The second one, and I should say should be a corollary of the first one. It's if you mean that circularity is connected with a very low rate of economic growth, I should expect a rate between 0 and 1%. You need to recycling a lot. And for the moment, the strategy in Europe and in many, many countries to recycling a lot. But the problem is we are not able to improve the recycling at a global way. We can do it at the micro levels, but not at the global levels. So I believe the idea that we have to respect the planet boundary, make just have one target, recycling more. And I would like to explain that this strategy, it's not a very good strategy. The second goals we have to introduce here is different scales. I would like to show you that most of the time we try to fix the micro level, which means we are very focused on the company's level, firms levels, sectors levels. And the problem is when you try to imagine what means circular economy, you need to have a global view. You need to have a macro and meso view. And for that, you see the limits of the scale. If you use a microeconomic scale, you don't understand what means about the rebound effect, for example, or you don't mean what means resource consumption. What resource do we consume today? Which one? And how we can reduce our consumption of resource. The last one, it's we forgot that if we talk about circular economy, it's not to build another economy. It's really to closing the loops. I mean, we have to close the loops for flows and flows connected to production and consumption. And if we are not able to close the loops, we cannot minimize our materials and energy flows. It's like if you don't understand the dynamics of the flows or the dynamics of the energy flows, you will not be able to understand what means energy or what means renewable energy. I just take an example. If you build a wind power, you have to be able to measure all the energy or the CO2 pollution you put inside at the beginning and at the end. So to do this, you need to identify inflows, outflows. I think we are able to do this even at a global view. But the problem is the connection with the stocks, because most of the time we measure the flows and we forgot there is stock somewhere. Can be stock of product, but can be stock of resource, of raw materials. And we need to engage a process to understand the feedback effect between the stock and the flows. Which means for the moment, when we talk about the stocks, we have a kind of representation of stocks about economic view. And you know that most of the time we explain that you have to reduce the stock to reduce the cost of production anyway. Here, it's really to understand what flows go in the system and what flows go out the system and what stocks do you have to measure. So it's not only a cost or a product stocks, it's really stocks of everything, energy, waste, food. And for that, you really have to be very careful of the different level you use. Last time, it's the time delays. Maybe it's hard time for that. Time delays means at the micro level, at the global level, try to understand, what are the consequences when you do something, and what could be the time delay you're going to measure. For example, if you try to balance a wind power, if you produce energy wind powers, you have to build the wind power, but you have to imagine the life cycle analysis. How much time this wind power is going to produce energy, and which kind of technology you're going to use to produce. So time delay is very important, and it's very hard time when you try to measure different quantity, which are not the same. It's not only euros, it's kilogram, tons, kilojoule. So when you're crossing the loops, you have to balance all the way to measure and all the way to have a global view or circular economy. So by these three aspects, three issues, I mean, you cannot thinking about circular economy if you don't design at the beginning the planet boundaries, the limits of the system. You cannot think about circular economy if you don't are able to integrate the different scales and have different measure at the different scale. A city is not a country, so you have to design whether you really want to define. And closing the loops, maybe it's a bigger definition of the circular economy, how you are able to closing the loops of the system. So when you do this, you make the connection. Planet boundaries means what could be the global view of the planet boundaries. And you know that we have today some design from Rockstrom about planet boundaries. And I think circular economy have to be connected to climate change, that we know we do it. but have to be connected to land system change, for example, or even biochemical flows. We know that it's very important to reconnect the flows of materials, and some big issue about climate, even biodiversity is connected here. I think I will show you at the end that the link between materials and energy, it's maybe the bigger issues today about circular economy, because we have to really understand that we need more and more energy for extracting materials today, for example, or we need more and more energy just to imagine what could be a renewable energy for the future. If I just go to the scale, I think we cannot decide to say, oh, we have to measure very specific levels, and the micro level is very easy to measure because we can have many indicators. We really have to integrate the scales. And when I say integrated the scales, that means we have to have different models. And these models give some signals of what you want to measure. For example, at the global level, we need to have world model. I think it's very important to have global trends of specific issues about climate, for example, or mobility, or food system, or population. So we need to have really good world model and be able in this model to push some circularity. For the moment, it's very hard time to imagine a world model with circularity. There is some feedback loops in the models, but we really have to understand what means this. And so at every scale, the big question is the cross-border. What is the connection between the global and the regional one, and the national one, the territorial one, the city one, or the agent-based model? I mean, if you decide to speak about circularity, about enterprise or firms, you have to connect it to this level, to some different levels. And you have to understand what are the best level as you make the connection. So you must have a box, a toolbox, a method box to do this. I believe today that the big issue is to reconnect two kind of models, the biophysical one and the socioeconomics one. For those who ever work on biophysical models, it's a very hard time. Very complex details, because you have to understand, even when you use raw materials, what's happened in the process, how you extract, what quantity you extract, and the consequence, for example, on CO2 emission when you extract raw materials. So biophysical, it's very important, but very hard time to design. And sometimes it's not easy to design a biophysical models at every levels. I mean, the global could be easier, but more you go to the local levels, for example, the city levels, much more it's hard, very hard to models. And it's why when we talk about integrated models, the big discussion today is how circular economy or circularity could be really introduced in the way to models, and how we can make the connection with socioeconomics models. But by socioeconomics models, I speak about behavior, rules, tax, norms, everything who lets you know that you want to improve circularity or not. And even when you try to integrate the both models, the question is if assessment. How are you going to assess these models? How are you going to assess circularity? For the moment, we really talk about efficiency. And if you check the different step from Europe since 2015, we are really focused on resource efficiency. I'm going to show you that it's important, but at the same time, we know it's very hard to balance efficiency principle with resilience principles. Sometimes when you improve efficiency, you try to reduce, or you reduce resilience, or maybe you reduce some other assessment you want to evaluate in the models. So the question of assessment, it's very important. And maybe the last one, this is the data. I think everyone is involved today about data. Data is not only to collect, it's just to monitoring. And I think when you have to design a kind of security, the really big deal today, it's really focused on data. I say Europe is really trying to catch and collect have many data collect. But even when you go to the local level, you have to find a solution and have a very good link with partnerships, stakeholder to collect data and to think about circularity. So if I introduce everything, it means, and all this issue, it just to let you know that build a box, a toolbox or a method box. It's first time thinking about systemic approach, how you build a system. And whatever you know or whatever you do, when you start to think about circularity, you need to have a systemic approach. You cannot have a linear one. You have to collect and try to fix the link in your system. You must accept a kind of complexity. It's very hard to work with a simplified model here. And sometimes some detail, too much detail, complicate the system thinking. So I still believe that system dynamics could be a good model, a good method to use it. But we have to reconnect system dynamics to different techniques like material flow analysis or life cycle analysis in the process. So if you do everything what I said, you can talk about indicators. You can have a discussion about which indicators you can use and how you can use them. But for me, it's not enough. I mean, if we are inside the concept or maybe the paradigm of circular economy, it means you imagine a new economy. But the question, it's not to imagine a new economy, it's to talk about circularity. And I still believe that if you do this, you have no choice. If you have to measure circularity, you have to rethink circularity in the economic side. And I still believe that the only way to do that is reducing the size of the economy. I will try to show you why it's important, because for the moment, the way we designed the economic system or the way we measure the economic system, it's only connected to GDP. And I think there is many issues with GDP. We are not really agree or maybe very happy with the GDP. But the problem is not the GDP. GDP is just to measure something. So when you measure something, you have to know what do you measure. And the big problem today, it's when you compare the GDP to the size of the economy, you start to understand that the size of the economy get bigger and bigger. When I say size, it doesn't mean only the way you capture add value of the economy. This is the way you understand the economic size. And for me, there is two dimensions. Commodification means if you check every country today, we get more and more goods with price, add value, demand, offer. And even now with health sectors or education sectors, the public sectors start to get lower and lower and the private start to go. So I just take the example because this is a new indicator of Bloomberg, who tried since 2019 to capture what means size of the economy. And so there is one aspect we have to introduce here. If the size of the economy gets bigger and bigger, and if you start to understand that the private sector start to get bigger and bigger, it means at one moment, the growth of the economy is higher than you really think. So GDP is not enough to understand things. I would say this is a part of the iceberg. You know, you see the iceberg, you don't see what's happened behind. This is the same with the size of the economy. It's very hard to capture all the growth of commodification. And maybe the last point, it's trading. We know that if you start to design trading as a driver of the GDP, for example, it means you forgot the footprint of the trading, I mean export and import. And we know today that the footprint of nation is very important. If you put inside trading, what do you export? What do you import? So if you accumulate commodification and trading, you start to understand the size of the economy and how people are really connect only with the economics system. So if you start to understand these 3 or 4 steps I was talking about, I think you start to design different levels of the circular economy. And I propose to have these three levels to understand how to measure. I start to believe we have today a very nice framework. If you check, for example, Ellen MacArthur Foundation, people are working about the eco-design, industrial ecology, economy of functionality, manufacture, repair, reuse, recycle. I mean, this is what we're doing at the micro levels for the company anyway. And I will show you that it's not easier, but it's pretty easier to measure something and to be agree on different indicators. Now, the big issue is to starting this, go to the macro level, because when you go to the macro levels, you don't have to focus only on waste. Waste is just the end of pipeline. The big one is extract and trade, because extracting need more materials and more energy. So you have to understand what means extraction. I just remind you that when you extract, you just capture free resource from the earth. And because extraction means a cost, you start to give a value to the materials. So this is the way we talk about the economic system. If you just leave the materials in the earth, you don't touch them. They are free. There is no cost, no price. So no scarcity, no abundance. Maybe abundance, but we don't use them. So I think that the big step here about circular economics extraction. And like I said before, extraction and energy, because you need more energy to extract. And I still believe today that we need more energy to extract today than maybe 15 years ago. So the big deal is extraction at the macro level and the trading, because most of the time we trade more than we produce. Export, import are really important if you try to fix the footprint of materials on energy. So at the macro level, we really have to focus on these two steps, because for the moment, we are really only concerned by produce, consume, and waste. So be very careful about what circularity you really want to be involved. And the last one, it's maybe if we could imagine a shift of paradigm and maybe to measure something, and I think Europe could be a very good area. It's to understand that circularity need to be reevaluated most of the time. We need to restructure, even to think about what distribution do we have. I mean distribution about add value, for example, and how we can relocate activities, reduce activities, I mean economic activities, before to think about recycling. I just coming back to my first question at the beginning. Recycling is a good answer if you still believe that you can have economic growth of between 0 and 1%, and try to imagine this world with 100% of recycling product, which is not the case. I think I will show you, but almost at least 12 or 30% of product can be recycling at the global levels. So we really have to reconnect circularity to a specific paradigm. And I still believe that the only way to do this is to reduce the economic activity and try to relocate at the same times. So if we do that, we can just check what we could say the big timeline of Europe in this. I try to remind you that we really start in 2015, but we really decided to engage in the process in 2019 with the European Green Deal, because circular economy was only one step of, I could say, one piece of the puzzle. And now circular economy is still to become a plane which we can involve energy issues, climate issues. So many issues are integrated in circularity. And to understand that the connection is very clear with the climate pact, or even the chemical discussion or biodiversity discussion. So I just coming back to the measure, I think the plan is really to have a global security and start to understand that this global security has to be measured, as the local security has to be measured. if I just focus on circular economy in Europe, it's still a global effort, I think, to speak about sustainability. And this global effort means you really have to engage the process to think about CO2 emission. And you see, since 2016, uh, thinking about circular economy, it just imagine to have a new economy to reduce CO2 emission. So we cannot disconnect. And the other one, it's how you measure some things has circular economy, which is not, I should say, a specific issue or specific terms. If you compare to food, if you compare to education, if you compare to climate, it means are we able to engage a process which the connection could be circular economy and specific SDG, for example. And we believe today that SDGs 12, it's connecting. And I would like to show you that it's not only SDG 12, it's all the SDG. And so if you want to do this, we have to measure and maybe use the targets and indicators from the SDG. So finally, if we try to reconnect everything that I was talking about a few minutes ago, we have to understand what are today the situation, and I will take the situation of Europe here, and what are today the focus on indicators. So could be a resource productivity, could be a CO2 emission, could be energy productivity. I start to believe that energy, it's a big driver for security. And understand if as a circular material use rate, it's relevant to engage the process to have this new economy. And you see for the moment, it's very low, at least 12%. So it means we have to really improve the system. Some people do and believe that, or we have to find another system, or when circular material use rate will be just a point, one driver, but not the only driver. And I think for the moment, we are too much focused on this. So if we do this, we can go to the methods. I mean, if you just check, because I think behind every indicators, you have some methods, and you have to design the method to understand why we decide to use the specific indicators. I will share my presentation in three parts. Like I said, I still believe that since maybe 2015, we are really engaged in the debate issue about resource efficiency. When I said efficiency, it means we try to optimize energy resource inside the process. And most of the time, the model use a production function. It means we still believe that we can improve the production process with labor, capital, innovation, energy, land. So we still believe we can improve this, and we have to find the good solution, the best solution of the system. So we try to optimize. To do this, we have specific models, what we call computable general Kelvin models. And if you check these models, I try to remember you that this model have been used by Europe in 2015 to imagine security and circular economy. And today, this model are used by Ellen MacArthur Foundation. If you check the report about this report of 2015, you find this model from Boehringer and Rutherford. And this model is a multi-regional models, and you have three issues, I should say three assumptions. Preserve natural capital, get the highest utility of product, and avoidance of leakage. If you check all the models in 2 years, many models try to use the CGE approach, which means most of the time you have a macroeconomic models. I mean, you try to understand what do we consume, invest, produce, and you try to reconnect this model with environment models. Could be a life cycle analysis, for example, or material flow analysis. So I should say this is the hardcore of the model today when we think about circularity. The other one, it's you have different models who have macroeconomic models. I mean, they are a very big conception about the macroeconomic system, but at the same time, they try to introduce input-output system analysis. So this model tried to put some simulation on what circularity we could have and try to involve some climate energy discussion. Most of them are econometric model. I mean, they believe that statistics and data can be useful to reconnect, and they try to make correlation between climate, for example, and human activities or energy use and specific activity like steel industry, for example. So we have different modules about this energy climate lens. So I call this part resource efficiency CGO models econometrics because I should say 90% of the circular models talking about this at the global level and the macro levels. So it's very hard to be away from this. Very hard because Europe uses models, and very hard because many today try to develop this aspect. So we have to go somewhere else. And I should say the other design, it's circular economy with closing loops. And today, the big issue is to reconnect, I should say, some tools that we used to use, like MFA, material flows analysis, life cycle analysis with system dynamics. I mean, we have to talk about feedback loops, stocks, time, delay, and flows, like I said before. I just emerged here two examples. Last articles in 2020 try to think about regional levels. And its regional levels, we try to understand what is the socioeconomic subsystem, what are the resource consumption subsystem. So we have to divide in subsystem and try to understand what are the connections. I should say it's not the same methods, but I should add that all these two methods are really focused on efficiency. So we have to develop new models to go beyond efficiency. It's part of the job, you know that you can improve efficiency, but it's not enough. We have to do something else. The other case, it's how to develop the specific circularity for different sectors. And I think about sectors who are really intensive energy useful. So steel industry, for example, or car industry are a really good example today to understand how you can close the loops and how you can just understand what's happened. The third question, it's if you just check these two methods, the system dynamics one and the CGA or efficiency, resource efficiency, you start to fix another way to use it. It's resource efficiency, like environmental footprint. And now I'm coming back to the company levels. I mean, the micro levels, because when you are focused on resource efficiency, you have a broad category of resource. Energy is one, but you have land, water, biomass, food. So you could have a balance of every resource. And I believe that every company could find specific indicators to do this. At the same time, resource efficiency are connected to pollution and waste. When you use energy, when you produce product, you have greenhouse gas emission. So if you check today the companies and even the city, because the city uses the same indicators, you have resource indicators, pollution indicators, and waste indicators. I mean, it's energy consumption, water consumption, CO2 emission. If you check this, it's very simple indicators. I should say they are very simple because don't forget that many companies has many areas in the world. They don't have one plant. You don't produce everything in France. You have your company in France, but you can have like 5, 60, 70 plants outside the country. So if you want to compare, if you have to sustainable strategy, and if you're to talk about circular economy, you need to have very simple indicators. If you don't do this complexity, it's very hard. How are you going to compare a plant in Brazil and a plant in France? So the context, it's very different. So you need to have a very simple way to measure. So if you do everything what I did and what I said at the beginning, try to have the methods, you start to understand how the indicators are really linking to the way you designed the system. And start to believe that today, every indicators are connected to a different way to understand things. If you start at the micro level, you can be really involved by industrial ecology toolbox, and MFA, LSA going to be the methods to create the indicators. And maybe what's changed in the system is the way to take care of the resource. If you focus on energy, stream, water, waste, there is a different way to measure. The same for the connection between the biophysical models and the socioeconomic models. Like I said, it's a very hard time to build a biophysical models, even at the global levels or the local levels. But after, I think the great job is to understand the link with the socioeconomic models. And you say there is a kind of feedback loops between the two. You need to understand how the economic model makes some pressure on the biophysical model, but you need to understand how the biophysical model gives some limits to the economic system. So the connection is very important. And we have to imagine what could be the scenario. And I start to believe that when you build indicators, you need to involve scenario in the indicators. It's not only something different. Scenario has to be connected to indicators. So when you do this, you can start to talk about indicators. You can start to try to understand what we're talking about. If you take Europe as an example, you know that we try to monitoring a kind of framework on the circular economy. And the design, we have 4 thematic issues: production, consumption, waste management, secondary raw materials, and competitiveness and innovation. And if you go to the database of Europe, you can find all the data connected to these 4 issues. If you just check the table, we are around like 15 indicators, not only 10. It's because we try to understand more and more what we can measure and what are the connection between the indicators. I'm not going to discuss all the indicators. I will have maybe need 1 or 2 hours more. I would like just to take a few examples to show you that what we measure and what are the discussion behind, and maybe we could conclude on what do we know today. If I take the first one, that's production and consumption. We have one called European self-sufficiency for raw materials. And you see that the big discussion today, it's the raw materials we use for new activity, new technology, new energy. And we are talking about dysprosium, europium, magnesium, like phosphorus. And when you do this and you check this, you start to understand that Europe, it's not sufficient at all on these materials. And even some that we are sufficient, like indium, we start to see today that we use less and less indium because we have new materials coming. So the big deal today is how we develop this new economy with much more security, and maybe with the problem of security of materials. I will not go to the discussion about raw materials and to say, do we have or not, or are there a scarcity or abundance? I think there is a big discussion of this, but the connection is what with the product we use or the activity we do. And for example, electric car makes a discussion about lanthan, cerium, praseodymium. Even like power plants make a discussion with neodymium, dysprosium. So one of the big deals today for security question and sufficiency question, it's to make the connection between the resource, the production, and the way we believe production is connected to consumption. And maybe you check on my screen. There is a big discussion about China and about how China has much more production about raw metals. The question is not only China. The question is the country who really have this resource and this country who want to use it or not to preserve for security. And we know that some countries use them like security for the future. So I will show you at the end, but this discussion could be start to understand how we have to see circular economy in the future if we start to use these materials. Another example, it's a generation of municipal waste per capita. And you see, if you compare different countries, or if you take the European levels, which are 492 kilograms per capita, the question is how we really design this like a security approach. For example, if you use a city, you have to understand how, for example, you start to share or design your waste system, and how maybe organic system or organic waste will find a different pathway from inorganic waste, and how you build this. It's not only a question of metabolism, it's really a question about how you anticipate the growth of waste, because we have many cities today who are to manage organic waste, and how to do this. I think it's really important. If we check, for example, generation of waste excluding major mineral waste for domestic material consumption, I put you here the diagrams of resource productivity and domestic material consumption. I think there's a big question today. If we start to understand the way of each country have a different design of the footprint, we start to understand that GDP is one aspect of the discussion, but the big aspect is a material footprint. And if you do this, you start to understand that the big question of decoupling start to be a big issue here. Do we believe that we can decoupling the question about economic growth and consumption? I think it's a very hard time, and many reports put the limits on the way to understand decoupling. If we go to the manage, which is the second topic of these indicators, you have 6 indicators. Most of them are really focused on recycling rates or specific waste streams. I mean, packaging, plastic, for example. We talked this about 1 month ago, bio-waste, e-waste. If we do this, and I'm coming back to my first discussion, it means we are really engaged in the principle that we have to recycling most of the materials. I still believe we have to do this, but it's one way. We cannot focus only on this aspect. Recycling is just one design of the system. And if you check the design to understand what are today the connection with the system, you know, I'm coming back to my link at the micro level about trading and extract. If you take the example of plastic waste, you see that we improve the recycling rates years after years. But the big question is, what do we import and what do we export? And to know that if we, for example, recycling inside Europe, or if we're recycling outside Europe, because if you're recycling outside Europe, export go up. And if export go up, you understand that the Diemer going to go up too. And this is what's happened today. We export most of the plastic waste to Turkey. It's a growth of 66% since 2004. And at the same time, the export to China just go down. I think it's very interesting to see that in 10 years, Europe changed his mind and changed the way to export waste. No more in China, more in other countries. And you can check that for every waste in Europe, for example. Same discussion about import of waste. But now I think we have to have a pragmatic discussion here, because the country who really have this problem are countries that are Iceland or kind of Iceland. And it's very tough when you try to understand import, export, because Europe have to do this. So you find a big connection between United Kingdom and Europe for importation of waste. I should say, and we will see that, because, you know, the waste are a big issue here. You find this connection with every resource in Europe at any position. The third category, it's raw materials. You have 3 indicators. I should say the one that we are really focused on, circular material use rate. And, you know, I'm coming back to my idea about reuse or recycling. For the moment, if we have a percentage of material input for domestic use, it's only about 12%, almost 12%, which is very low if you compare to every activity we could involve in circularity. So maybe when we say closed loops here, it's really discuss what means closed loops, how to reintroduce materials and products in the economic process. Because recycling, it's one aspect, but I will show you, we need to design new aspect, new activity, new design in the system. And the connection can be very smart to do with which material we import, for example, or which material we can recycle. And I think the city level, for example, or the regional level could be very interesting to understand this. If you talk about raw materials, you understand that circular material use rate is very important. But I would like to focus on trade in recycling because this is a big deal about the circularity. If you check today, the trading of Europe and the way to understand import and export of recycling raw materials, I just remind you that we have many categories of waste. So all the categories are inside: plastic, paper, metal, iron, steel, copper. So we have a bunch of materials. At the same time, we try to understand how Europe trades this. And you see, we have the same consequence. If you check export, we export a lot, and I think it's very high. It's like, if we believe today, it's almost 26 million of tons. And if you compare to imports, we start to have limits of imports. But I think what is very important, it's we change the way to export today and the way to import. If you check, for example, the country which receive the raw materials or the trading, Turkey start to become the first partner of Europe. Same for Indonesia, China, and Egypt. And if you just cumulate the number from Indonesia, Egypt, you have, and India, you have the number of China. I mean, when I say we reduce connection with China about waste, we try to reduce the connection with China about recycling raw materials. So it's a strategy too that we design. If we go always the last category, because the last category is jobs and growth. You say it's a very hard time to make the connection because now we're coming back to the economic system. And the problem is the way you see the economic system, the way you see how is the security. So if you still believe that economy produces jobs and growth, yes, you're going to make the connection with security. But if you start to believe that circular economy is not really able to create the job we need or the growth we expect, the connection is very different. And for the moment, the indicator that we use here is gross investment in tangible goods, number of persons employed, and add value at factor cost. So if you check, it's all this high driver for growth. So I'm just coming back to my first question. If you try to measure security and your system is growing all the time, it's not possible. It's like take a picture of something which is changing all the time. So we have to understand this. And if we understand this, we can understand circularity. So if I'm talking about all this, or maybe I didn't make a comment of just this aspect, when I said circularity has to be connected to economic growth and we have to measure economic growth with specific driver, you see that one of the specific driver is innovation. I mean, it's technology. And if you want to measure the big measure of technology, it's patents. And here you see the big difference. All the patents coming from ASEAN area. I mean, China, Hong Kong, South Korea, Japan. This is a country who produce today more patent to recycling and secondary raw materials. Look, it's one of the big issue here to reconnect. because we don't speak only about materials, we really speak about recycling. And when I said, if you really want to have this kind of economy who accept very low economic growth, but recycling a lot, it means the paradigm, it's just this. You don't imagine new solution, you don't imagine a new aspect or new shift of paradigm. So maybe for discussion and not to go so far, I think we really have to be very careful when we measure something. I still believe that we have a very awful tendency to produce restricted security indicators. Most often it's the micro indicators, enterprise, sector level. And I think when you do that, I think we need to do this, but at the same time, we lose the global view. We lose the condition to create circularity. I just show you what we call the Sankey diagrams. It means Eurostat use a way to capture flows. Flows are really important for Europe to understand what materials we use, what energy we use, and what we can reduce or not, what we export or import. But you understand that materials flows is necessary, but not sufficient. We need to go beyond this. And I should say, this is maybe the first concluding I would say, it's be very careful the way we captures the security. And the global view is not sometimes enough. The second one, it's if you imagine a transition toward a circular economy, it's not only just recycling. You really have to improve all the big R of the security. And when I said system dynamics is useful, or when I said life cycle analysis is useful, it's just to say that we have to develop this part in the process. If, for example, at the company level, or even at the national levels, you are not able to have a very big detail understanding of what means product reuse or what means product recycling or repair, you will be focused only on recycling aspect. So I think there is a big issues here to develop. It's to develop the other R of the security and not only to focus on recycling. And for me, I'm coming back to my first step. It's the micro levels. Recycling is the end of the pipeline, but really to understand everything, we must develop the reuse and repair aspect and maybe understand how life cycle analysis is different if you reconnect to this different R. So be really careful if you think about recycling. I'm coming back to my first hypothesis. Even when you expect a very low economic growth, you cannot expect to go to 100% of recycling, and you have to imagine different strategy. Repair, reuse our strategy, and not only at the local level. The third conclusion, it's you really have to reconnect circular economy to the footprint of nation. And I should say to the dreading issues. You see, I'm coming back to my micro levels. I think for the moment, we are really involved. We are really focused on the connection between produce, consume, and waste. I think it's really good to say that we have to produce less and less, be efficient. We have to consume less and less, and maybe more responsible. And if we do that, we have less and less waste. But if you're coming back to the beginning and coming back to the way we are connected, extraction and trading are maybe the big driver of the system, and we are not talking about this driver. If you just check, this is the curve from not Europe, it's from UCA, because it's interesting to compare. You check that, yeah, production creates CO2 emission, but the way we consume creates more CO2 emission because we involve here importation and exportation. So maybe one aspect, and I will show you after, but maybe one aspect of the system, if I involve trading issue, it's just relocation. Relocation is a good aspect and a good strategy to reduce trading issues. So we have to focus on the specific R, relocate materials, relocate production, and maybe consumption at the same time. So we have to measure this. And I think it's a big issue because you know that trading, it's one driver of the economic's growth. And for the moment, we didn't use this driver of indicators to have a good pictures of circular economy. I take an example. If you show that one country or one area reduce export or maybe reduce import, it's not really good for economic growth. So, and maybe you're going to do everything to make more export, because you know that if you export more, you get more euro and more add value. So we have to make a feedback loop between trading with the economic growth and trading with footprint materials. And I think the only way to do this is to be able to reduce the trade and have a local conception of circularity. The two last point I would like to just mention, it's there is another R that we sometimes forgot, reducing. And when you say reducing, it's not only reducing the size of the economy, what I was mentioned before. I still believe that it means a shift of paradigms. When we talk about degrowth, for example, and I still believe that degrowth can bring a very add value to the discussion. Degrowth means we have to really think about how we evaluate circularity, how we evaluate our activity, what do we produce, what do we consume. And if we do this, we are able to reconceptualize. I mean, yes, produce for what and for who, and which add value we're going to distribute. And you see, if you are these 8 R's that Serge Latouche are talking about, it's not only an utopic discussion, it's really start to have a shift paradigm to understand what means really measure circularity in the system. So for example, we could have an indicators to how much activity we are able to relocate every year, how much activity or product we can reuse. And I think if we do this, we start to understand the consequence of security. I should say the bigger driver of the system, it's reduce, because you know that if you reduce extraction, you reduce trade, you reduce production, or maybe some other activity. My last comment, it's about what I said at the beginning. If you speak about circularity, but you are not able to make the connection between materials and energy, I think you don't really understand what means circularity. You know, as I know, but we consume energy more and more. And I think if we check today, the tendency of energy consumption, it's very high. And I said, even if you use more electricity, the big problems will be, are you able to produce enough electricity for the future? So it's not only to change energy, it's we need, and we will need bigger energy. And we know that to extract materials for the future, we will need bigger energy. So the question today is how we make the connection if we involve circularity between materials of energy. I will finish on this last diagram because I think we mentioned this at the end of 2019, but we didn't see what involves these diagrams. For the first time in 2019, you know, I should say the consumption of coals was the same as the consumption of renewable energy in the United States. I think they're very important information for that, because we could say, oh, very good about circularity, because about CO2 emission, very intensive industry using energy. And people said, oh, this is maybe, you know, at every time you need to have I should say, a very high point, or you said, oh, we start to have this new scenario and we are engaged in this process. Except that you forgot that if you check the energy production of United States, coal is using for electricity, and 90% of electricity coming from coals. So it means if you start to imagine that security means only to change of energy, it's not enough to imagine what means security for the future. So the big deal today, if you are growing, if you consume more and more energy, is the consequence of the source of energy you use. And electricity doesn't mean you use renewable energy. That it means only that the part of the energy that you use is helpful to be produced and helpful for the people to consume. So I still believe that this driver, the connection between materials and energy, will be the cornerstone on security. And if we are not able to make all the connection, we are not able to really match this. And if we want to do this, we have to put more complexity, more feedback loops in the system to understand this. And the only way to do this, it's really to modules, create some modules from energy, materials, and reconnect this at the global level, at the local level, because I still believe that for the company, even for the city, it's very helpful to see if you improve one aspect of the circularity, you don't produce problems for other aspect or other issue. It's like, you want to reduce the waste and you don't focus really on the food system and how to engage the waste at the beginning of the food system. Okay, I think I'm pretty finished with what I wanted to present you. It's only 2 o'clock, so maybe I took much time to present everything.